Hi, here I'm going to present Gemma 3 model. Uh, this is some open weight models that Google released almost in I think February or March this year 2025. Um, One thing that I like about this model is that is obviously is open weight models. It comes with three sizes, and those three sizes, sorry, it comes, yes, it comes in four sizes actually: 1 billions, which is just text only; 4 billion, 12 billions, 27 billions. Today I'm going to talk about mainly about the 4 billion models because that's what I can load in Google Colab. But it would be nice to also try the 20 billions and 27 billions, where we probably need much more memory, maybe as high as 3 times or um, 6 times higher memory. The GPU that I'm using is a free GPU from Google Colab, so I tried the 12 billions and I ran out of memory, so I'm going to stick to 4 billion. That's one thing that I was going to say. This is a good article that kind of goes through the technical part of Gemma 3. A few things that I wanted, so it's good to go through this if you guys are interested to learn more about it. One high level things I was going to share about the capabilities of these models is obviously the 4B, 12B, and 27B are all multimodal, so you can give text and image, and that's what I'm going to show here. I'm going to test some of the capabilities of text and image and see how well these models perform. One other interesting is that the context window is 128k tokens, which is great. And then a few other kind of improvements or architecture improvements that has happened in this model. So yeah, so the first thing is this visual is VLM, is visual language model. As you can see, you can feed the image, and it goes through the siglip, which is again from Google. I think is a encoding layer for image, and then you also feed your text to the tokenizer, so you have these tokens from image and text, and then you basically flatten them and you concatenate these two, and then you pass to the Gemma architecture. So this is cool. You guys can read uh, more about it. The other interesting part that I really still need to look deeper is that uh, sorry, in Gemma 1 it seems that they only had global attention. When you kind of pay attention to the entire context or entire window, context window and the tokens, but in Gemma 2 and Gemma 3 they came up with some kind of improvements, and what they did, they came up with the local and global model. So the global attention layer here, while it pays attention to the entire context, the local attentions, they have a limited window for attention. So basically you attend to, let's say, 10 tokens around you. I don't know exactly what's that parameter, but and then they interleave in geometry local attention and global layers. So that kind of mixture of local and global models, I think they get a bunch of benefits, specifically the KV cache memory usage, so they can increase the context, long context, while the KV cache memory doesn't grow quadratic as it used to be. So that's also interesting part if someone wants to read more about it. What else? So those, and then yeah, and then there are more details here that still I have to read more carefully. But without wasting more time, let's go and see how this Gemma 3 4 billion parameters is going to work. I'm going to push this repo um, to GitHub, so you guys can also have access to it if you want to try it yourself. But I'm posting this some links here for if you guys want to read more about it. So these are extra links that you guys read. So basically we install the transformer from Hugging Face. We install this model is gated, so you need to also log into Hugging Face. That's quite trivial. So a bunch of imports. I already logged in, and now here I tried to by the way, as I mentioned earlier, 12 billion parameters, but it ran out of memory, so I'm not going to try that for this demo. But the 12 billion, sorry, 4 billions we can successfully load it in with 16 gigabyte memory limit that we have with T4 GPU. Okay, so we are doing that. And okay, let's look at the first image that we have. So we have this image. This is some example that I took from other people notebooks. So essentially there are, I think, 19, if I'm not mistaken, dogs here, and we are going to prompt basically the image to the Gemma 3, okay, as part of the image type, and then we're also going to ask how many dogs are in this. That's our user prompt in this image. So let's run this, and then see if the model hallucinates or how good is in counting. And this might take a while. Okay, it came back with the answer. It took almost 10-ish seconds. So so essentially it predicts 22 dogs. Okay, if you look at the number of dogs, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19. So the estimation is not correct, but it's also predicting some of the types. If you rerun the code, you will see that there is obviously randomness in the output of the Gemma, basically three the output of the Gemma architecture, because it's a essential LLM is not deterministic, so there is randomness, so the answer might change every time that you hit it. So okay, this time came with, oh, there are 20 to 25 dogs in the photo. Okay, so it's different than the previous one. Let's move on to more interesting example. This is an interesting example that I personally kind of took it. So it's an old building. So let me show you guys the what we are talking about. So it's an old building. So it's an image from an old building. It's an electrical panel in San Francisco that I took the picture myself. And one thing that I wanted to show is, sorry, one interesting about this image, if it shows it properly. Okay, yeah, if you look at this image, is that, okay, you see circuit breakers in this image, is electrical panel, and we see some brand. Let's see if it should be easy task, but let's see if you ask basic question about this image and say what you see in this image, what would be the response. And then after that we are going to ask more specific questions by saying that, do you see circuit breakers in the image? That's more specific. Or do you see fuses in this image? What brands and models you see in this picture? Okay, so more specific, but we will try that as well. So one thing that obviously we are seeing is that the speed, although this is 4 billion parameter model, the speed is not that fast, at least with this T4 GPU that we are trying. Okay, it came back okay by saying the image electrical panel, great. Breaker switches, it says they are all in off position. I don't know if that's correct. No, they are not in off position. It's kind of confused. Off position is the other side. I mean, no, this was the building people were using electricity, but it detects all the labelings, no, the brand of the panel and such. So this is good. Let's hit the image again, but this time specifically asking about the brand. Do you see circuit breakers or fuses? So this could be an interesting use case. Let's say I'm not the electrician, I don't know that much about how the electrical panels works. What is circuit breaker? What are the fuses? And I just want to kind of see if the model understand that part. So based on the appearance of the switches, these are circuit breakers. Okay, that's correct. Not fuses. Okay, that's correct. And then it comes back, the main panel is labeled easy stack. Okay, so I don't know if this is true. I have to review this if this is correct, but it detected the brand as we saw in the previous image. Sorry, in the previous hit. Let's look at the second image. This is an image that I took a week ago from SF, from San Francisco, from sorry Salesforce office. So let's hit the model and then ask what city is this. It should be kind of obvious because of the buildings and the Golden Gate Bridge in the back, but let's see if the model also can detect that. So this is kind of scenery. So it finds some buildings. Suspension bridge is the, I don't know why it says San Francisco Oakland. That's not San Francisco Oakland. I don't know if I see San Francisco Oakland in, I think I'm facing the Golden Gate Bridge, but for some reason it confuses that with the Oakland Bridge, which is not correct. But at the end, okay, here, based on the three clues, the city in the image is San Francisco. At least detected the city correctly. And the next image is another electrical panel picture that I took like a few weeks ago. In this building, I think what we are seeing some, we are seeing some fuses. I think these should be fuses based on what I understood. But let's see if um, the the model also see same thing, or if it hallucinates. By the way, these are all tests are the results of 4B. I assume if you switch to 12B or 27B and test them, the model should perform better. So keep that caveat in mind while we are going through this test. So it says it's electrical panel. Okay, it counts 5 of them. 1, 2, 3, 4, 5. Okay, correct. And then what else? So it's not really talking about fuses versus circuit breaker. Let's hit it again, but this time ask specifically about if the model sees circuit breakers or fuses, and see how it responds. Okay, presence of circuit breakers versus fuses. Circuit breakers, not fuses. So I think this is hallucination. All of the ways look like they have the standard lever or button for tripping them. Fuses are generally circular and require manual replacement. So maybe I'm wrong, but this to me seems a bit old. But it doesn't recognize this as circuit breaker. I should have opened them to know for fact, but it doesn't agree with me. Let's try another picture, which is this is basically Powell Street in San Francisco. Is basically the train that tourists takes. Let's see if the model understand this. This other kind of should be easy task based on the clues that you see in the image. And then we can move to the harder tasks. By the way, this image is big, so the size of image is not as small. And I think the way that they do it, they do pan and span, so they chunk the image to bunch of 896 based on what I understood, 896 by 906, and then they tokenize them. So okay, it came back. So it seems so it's okay. There's a lot of explanation about the details. I didn't specifically ask about the city, but let's leave it alone. Let's go to the other one. This is another landscape in San Francisco from Pierre Street. Um, let's see the model detects what city they have taken this image from. This should succeed. The next task is much harder, and I will explain why it's much harder, but kind of more interesting, I would say. So that this finishes, and then we can run the next task. Um, the next, let's wait. So okay. Oh, so it couldn't detect the city this time, but if we rerun it, see what happens. Um, so it didn't succeed detecting the city. Oh, okay, let's increase the number of tokens for the output and rerun again. Okay, okay, Santa Cruz. So okay, it hallucinated. Let's go to the next task, which is more interesting, um, and more valuable from business point of view, and I will tell you why. Essentially, what I'm doing is that I have a document about the cash flow. This is a PDF, which is the cash flow of a building. Okay, so it's a new, basically, is a it describes the cash flow. It describes all the months, the income. This is about building the revenue income from the rents, all of the basically costs, expenses, including um, management fees, um, different type of costs, like repair and maintenance costs and such. Anyway, this is a number of pages. So what I'm doing, I'm basically reading the PDF and I convert each page to an image, and I'm feeding the image to LLM, and I'm asking that, a specific question about, let's say, the total operating income. What is the total operating income? So this is a bit tricky problem, but it's supposed to hof- hopefully see how well it does. So does can the model read the total operating income or hallucinates? So let's do the first page. So this is the first page that I just showed you, and what I'm going to ask is, what was the total operating income? Okay, let's see what would be the number. What we should expect as the total operating income is $138,309 and such. But because there are column reports for each month of 2023 for this page, so the model has lots of, because of this format and structure of the documents, there are lots of room for hallucination and then get confused. uh, so how let's see how 4 billion parameter performs. But and then again, it would be very interesting to also see how larger size version of this model perform for the same task. So if you try larger size, and then please share your experience. So it comes back. Let's break down the calculators of the total operating. It's interesting. It wants to do the calculation again for us. Identify the relevant operating income, sum the value for each operating income line. Okay, add all of them. Okay, sum them. Okay, and then it comes with 159,000. So first of all, it's interesting that come up with this number. I don't know where residential income is. Residential income is okay. So this correct. This is correct. The residential income is this much. That's correct. Fee income $420. I don't know where does that come. Fee income should be 432. I don't know where does 420 comes from. Key money. I don't know if there is something like that here. I don't really see that key money. I don't know where is that coming from. That's crazy. Utilities $1,000. Again, I'm not seeing anything regarding to utility in this page. Insurance $591. There is no any number on insurance cost, but insurance of this building is huge, so it's like in order of 30,000, and that's listed on the second page actually, if I remember correctly. See, here is the property and liability insurance is 38,000. I don't know how it reads such things from this page, so it's again purely kind of hallucination. The other crazy thing is that why do you sum them? Those should be the cost. So even doesn't have that level of understanding. Let's look at page 2. So this is the page 2 for cash flow, and this time I'm going to specifically ask, okay, what was the total property and liability insurance? What was the total property and liability insurance? Okay, and it should give us this number that we see here, 38,749. See if the model hallucinates again. So the model is trying to read some of those information. I think this is a very interesting use case for VLMs, those kind of documents that they have this kind of more complex structure can be used with VLM as kind of OCR technique to parse these pages. Okay, come up again with the formula, and then the total. It says scroll through the document until you find the section labeled. Okay, yes, identify the relevant rows. And it's interesting is reasoning. Some of the values. Property insurance 15,000. Where do you see the 15,000? I don't see anything for 15,000. This is the liability and insurance, which is 38,000, and excess property insurance again. Where do you see 1,480 number? I don't know where does that come from. Probably one of these columns. It randomly selected some of these columns for whatever reason, and some of them and came up with the wrong number. Anyway, the last test. I'm going to ask the same question but about property taxes, okay, and I expect to give me this number, $6,697. What's the property tax for 2023? 16,000. Okay, again, I don't know how did it come up with this number, some other hallucination. So overall, what happens is that I think there is a Gemma 3 is definitely is a interesting model, is open source model, is has lots of use cases for VLM kind of problems when you have let's say image and kind of you want to process an image as we saw, but at least the 4 billion version there is lots of hallucination, as you can see, so it would be interesting to try bigger size model. Thank you.